Hey YouTube, what's going on? It's Adam here with Retro Repairs, and time for another repair video. So what I got in front of me here is an Atari 5200. Now, a lot of you probably have never seen an Atari 5200 before, and that's for good reason, because they really weren't very popular at all. This was Atari's successor to the Atari 2600, or the Atari VCS, as it was earlier known as. Atari was pressured to make one of these, mainly due to the release of consoles such as the ColecoVision or the Intellivision, which had better graphics, a little bit bigger games, and basically they were leaving the Atari 2600 behind. So Atari tried to compete, came up with this absolute monstrosity of a console. So I want to give you a comparison as to how big this thing actually is. That's a Nintendo Entertainment System. Oh, I got one here. This is bigger than an entire Sega CD, and much longer, quite a bit thicker too. So I don't think I need to keep talking to you about how big this thing really is. So let's try this out, see what we've got. Now, to hook this thing up, we got to flip this over first, and you'll see that Atari has the video cable wrapped up on the back of the console, which is kind of neat. Helps with space saving. Apparently I can't talk today. And it's got this handy RF plug, so easy connections, easy, right? But you'll notice, if you take a look at this thing, well, we got 4 ports on the front. There's nowhere for you to plug in power. So we've got a square and a circle switch here. There appears to be some sort of cover here. Yeah, but not very obvious what you do. So how this actually works is Atari made this beautiful little switch box that I'm sure a lot of you people loved using. So these would connect right into your TV, and allows you to switch between your TV or your game system. Now, they also had a power adapter. So I've already plugged this in. It's making a nice little hum. See if it's possible you can pick this up maybe. I don't know if you can hear that or not, but it's got 2 cables coming out of it. So one of it's got your standard plug, and one of it has this plug that you'll plug into actually the system here. So we plug it into power, and then we need to plug the game into the switch box as well. Don't know if you saw that, but there's a little bit of arcing when I did that. There it is. So, you know it's a really well thought out system when you see that. So, let's hook this up to the TV and see what we've got. Alright, so I got this beast hooked up, I think. Got her set to channel 3, and I go to push power. Nothing happens. Fortunately on this, there's no LED that I'm aware of, so I can't really tell for sure that it's actually thinking that it's on or that the switch works. So let's check out the back here. So this switch right here is probably for your channel 3 and 4 selectors. So let's switch that and see what happens. Still nothing. So I think we're going to have to open this up and see what makes this thing tick. As you know, I bought a few different 5200 games, because 5200 games are actually pretty cheap, and I managed to get these in box for I think like $5 each, so really can't go wrong. So let's open this up, see what's going on. All right, so should be able to flip this over. Oh, and there goes a screw. And hopefully this just lifts straight up, and it does. So here we can see the guts of this. Okay, so taking a quick peek, I see what looks like an empty RF out. This is the RF/power cable, so it appears like it's connected. Gonna have to come back to that and see if there's supposed to be a purpose to that or not. Okay, so first thing I want to do is check that this board is actually getting power. That could be a very easy diagnosis. To do that, I'm going to check out this voltage regulator right here. So what this does, this takes the input voltage, which I believe is 9 volts, and it changes it to something that the board can use, which in this case is 5 volts. So this is a 7805 voltage regulator. So these 3 pins, the one on the right is going to be your input voltage, the ground is in the middle, and your output voltage on the left. So I expect I should get about 9 volts coming in through the input voltage on the right. So I'm just going to touch something grounded, touch the right one here. I'm getting 0 volts. Let's try hit the power switch. Again, 0 volts. Same thing with the output. 0 volts. Just going to try that again, but hitting the ground rail just in the off chance that the ground here is broken. Output 0 volts, 0 volts. So this voltage regulator is not getting any power. I'm going to try it with a game in just in case it has some sort of circuitry here that, well, appears I can't do that. Just for your view, on the input side, no volts. On the output side, 1 volt. So, interesting. Let's follow a little bit further. So looking on the back of this power supply, so this supply outputs 9 volts AC. So that means somewhere here there's a bridge rectifier which changes this to DC, but on this side of the plug it should be outputting AC voltage. So I put my multimeter into AC mode, and if I shove the negative in the middle and touch the outside, I should get 9 volts. Oh, there we go, 10 volts, which is close enough, probably within spec. So that means that the power supply is sending out voltage at least to this RF switch right here. So I guess the question is going to be, does this cord actually accept that voltage? Let's try, let's see if this gives us any specs. It doesn't convert within here, eh? I don't think so. So let's see what this will do. So positive in the middle, negative on the outside. 1 volt. So this could be the issue here. Let's switch that. One volt. Let's make sure that we're getting a good connection. 1 volt. Let's try DC, just in case there is a rectifier in this part of it, which is possible. So straighten the bottom. Nothing. Let's try to just replace it. I saw a volt for a second there, but it's maybe just by wiggling even. So I think I might actually have to break this guy open. This could very well be the culprit here. So let's put the board to the side and take a look at this RF switch. Alright, so I have this plugged in, and we want to be very careful as this is live. It's not a lot of voltage, so it's not gonna, probably not enough to actually hurt anyone, but just be aware that this is gonna be a live 9-volt AC connection. Shouldn't be a ton of energy behind it, but what I want to do is just ensure that this board is getting voltages across it. So we're going to flip it over and test in AC mode that we're getting 9 volts. So one on ground, one on the middle here. Is it the wrong one? There we go, 10 volts. So we are getting 10 volts into here. So this would mean that, just reverse it just to make sure. It doesn't matter because it's AC. Let's figure out which one the, there it is. So my guess is, since we're getting no voltage across these, this will be ground. This will be the 9 volts going in here. So if I were to test any of these contacts to ground, we should also get 9 volts. 10 volts, perfect. So 10 volts is going into, where's it going? Going into here, right there, which means we got 10 volts going into this rectifier right there. So let's see what we're getting for output voltages on each of these. So switch it into DC mode, ground it here, and just test each of these. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So I'm getting nothing across all of this. So that leads me to believe that this part right here is defective. So I may need to get myself another one of these, or I can do a DC power mod, which I think is going to have to be the way to go with this, since this is a pretty crappy solution anyways. Let's skip this whole thing altogether and do a DC power mod and use a normal plug like normal people would do. Alright, so for this mod, I purchased an Atari 5200 AC or Switchbox Bypass kit, and I bought this from console5.com. They have a lot of different kits for different mods and repairs that you might want to do for a console. It also comes with capacitors for replacing, well, obviously capacitors. So I did note when looking this mod up that there really isn't a lot of good step-by-step documentation for this. So I've never actually tried to do this mod before, so I apologize in advance if it's a little bit slow, but I did find something that looks like it's going to be pretty good, so I'm going to go by that, and hopefully we're able to do this rather smoothly. So to start out, what we need to do is remove a couple components. Firstly, this capacitor needs to come out, and this is labeled C45 on the board. Now, this should be a much bigger capacitor. I'm not sure why it's so small. Someone clearly replaced that. It's supposed to be a 4700 microfarad capacitor. I can't read the label on it. Well, either way, let's take her out. There we go. So that first one is out. That's C45. Now the next one is going to be this inductor here, which is labeled L8, and that's that orange one. Looking at the step-by-step guide, it's actually supposed to be blue, but they may have had different revisions for this. So let's take that out though. And there we go. So those components are now out. So the next step of this is going to be to install a 47 microfarad capacitor in place of that C45, which was supposed to be a 4700 microfarad capacitor. Now, the two capacitors they sent me include a, let's see if we can zoom well enough, It's not really focusing, but that's a 10 microfarad and a 470 microfarad. So I suspect they accidentally gave me a 470 versus a 47. However, that capacitor I just took out just so happened to be a 47 microfarad capacitor. Nishikon too, which is, or Nikon. That's a knockoff brand, but whatever. Which happens to be exactly the size that we need. So I'm going to reinstall this capacitor. If you're following along, you're going to install your 47 microfarad capacitor. And that's just going to get soldered right into place. So now that the capacitor is installed, there is one thing I want to point out. On my board, there are 2 holes on the negative side and 1 on the positive. However, the guide that I'm looking at has a slightly different board, and it looks like there's 2 holes on the positive and 2 holes on the negative side. And in fact, if I scroll up to the point where that capacitor came out, there's 6 holes altogether because the capacitor itself had 3 terminals. So the next step I'm going to do slightly different, but there's one of 2 ways that you can do that if you're following along. If you happen to have the board that has 6 holes, the next thing you're going to want to do is take this diode, and the side with the band on it, you're going to want to put it in one of the other positive holes. Now, since I don't have, that was my multimeter. Since I don't have extra positive holes, I'm going to have to do this on the back side. So let's flip this over and take this game out. Let's flip this over here, and that's what we're looking at. So right here, I lost it already. Right there, that's where that capacitor was. So the side with the band is going to be connected to that there. So I'm going to trim this leg a little bit so that I don't have too much hanging off, and I'm going to figure out which way I want to orient it. All right, so I'm going to have the power jack pointing out towards the back. So what I do want to do is orient it this way, and there's also just less stuff here. So I'm going to trim off the leg a little bit, get my soldering iron, and just add some solder to that leg itself. Just like so. Actually, that's probably still too much leg. Then, just going to line up the diode with that positive terminal, or that positive end of the, let's get my tweezers, that positive side of the capacitor, and then solder that leg right onto that solder that I previously used, right like so. There we go, that should hold. Just want to make sure that it's not going to short against the negative side, and it's not going to bend that way, so we should be good. So now the next step is going to be soldering a wire onto the opposite end of this diode. So what I want to do here is, again, we're going to trim this back to right about there, let's say. But I want to get a piece of heat shrink tubing. So it should be an appropriate size. We want it big enough that it's going to slip over top of the diode. Just like so. That'll be perfect. So I'm going to cut that back a bit to size, maybe about like so. Yeah, that should work nicely, I think, right there. And I'm just going to run it up this wire for now. Get it well out of the way. Getting my soldering iron again and my flux. I'm going to add some flux to this wire and then tin that wire. So just like so. Just going to load that up with solder so that it's going to want to immediately easily bond with this other leg here. So I'm going to heat this all up. There we go. So then I'm just going to run my heat shrink tubing all the way up over top of that diode, and then just going to turn on my hot air and shrink it. Perfect. So apparently I've got some audio problems, so I have to do a voiceover now. But what we're doing is we're getting this black wire, and we're going to put it onto the negative terminal where that capacitor was. So I'm just going to line it up. I think it's a little bit too big to fit in the hole. So what we're going to have to do is just fill that hole up with some solder, and then we'll be able to solder directly to that blob that I'm going to put there. So get the soldering iron warmed up, and heat up that pad, and just throw some solder in it. There we go. Now we got a nice little ball of solder. So now I'm just going to grab that black wire, and we're going to do the same thing as we did with the red one. Going to tin it up, so apply a little bit of flux, get some solder on my iron, and just touch the wire. The wire should soak up a lot of that solder. There we go. Need more solder. And you saw how quickly that wire turned silver. So now, just a matter of touching it to that blob that we left. Heat up the blob, and should be pretty straightforward to get that solder in there as long as you line it up properly, like I'm apparently struggling to do. So now we're going to get some heat shrink tubing and just cover up the exposed wire here, so that way it's not going to short against any contacts nearby or move and touch that positive lead or anything like that. So just going to run that heat shrink tubing down the other side of the wire and bring it right up as close as I can to that joint that I've just made. So just like that. Now I need to get my hot air gun going again, and I'm just going to shrink it into place after some fine-tuned adjustments. There we go. Feel like I'm doing a director's commentary. I guess kind of technically I am. And perfect. So now the final part of this power mod is going to be attaching the power jacks. So you need this capacitor, which came in the kit. It's a 0.1 microfarad capacitor. It's ceramic capacitor as well. So if you have a selection of those, or whether you order a kit, you'll just have to make sure you source one like that. So what I want to do here is run it through the existing hole in the shell, so that way I don't have to actually drill anything. However, the problem, as you can see, is the jack that they've sent me is just a bit too small for that hole. So I'm going to have to try and find some sort of washer or something so that will hold in place. But for the time being, I'm going to hook this up so that I can determine whether or not this power mod actually works. So first thing we need to do is strip these wires just to expose enough lead to work with. So there's the positive, and here's the negative wire. And I'm guessing what I'm going to do next is flux it and tin it. No, I'm going to trim it a little bit. And now the flux pen for everyone that loves seeing all the flux. So get that fluxed up just so that it's going to be prepared to accept more solder. I'm going to load some solder up on my iron and just once again come in contact with those wires. Those wires will suck that solder right up. And perfect. So this is the tricky part. What I'm doing with this capacitor is I'm actually sort of bridging these connections. So one of the terminals is, or one of the leads is going to be attached to the positive side, and one lead will be attached to the negative side. So this can be a pain sometimes if you don't have a helping hand, like I don't. So that is one thing I've been meaning to get around to buying, but I just haven't done it yet. But once again, it always helps just to tin it a little bit, get some solder on that leg so that it's going to be more receptive to bonding with that wire. So once you finally get them lined up, heat them up, get some solder on there, and hopefully that's good. So now what we're going to do is get that other leg of that capacitor and attach it to the negative terminal. So I found that it helps to actually hold both of them together with a pair of needle nose pliers or something, just to keep them together, and then you can introduce a bit of solder to tack it in and then come back and fully make a good connection. So that's what I'm attempting to do here. And go tack a little bit of solder in there. It should wick up into that twisted, stranded wire. There we go. Now come back and just top it up with a little bit more solder. Hopefully it doesn't pop apart. And it looks like we're okay. So what we need to do here now, just to protect these capacitor legs from shorting, just add again a little bit of heat shrink tubing in place. And that's just going to keep it so that when these get pinched together, it's not going to short that connection. Once again, just get the hot air gun going and watch it shrink right into place. So now what we need to do is get this this power jack ready to be soldered onto these wires. So what I like to do, just try and put some solder on it first, and that will help to solder the wires directly into it. It's a little bit more difficult to solder it to, I'm going to call it a dry connector, so having a little bit of solder on there ahead of time helps. So you fill up that, the pin in the middle is going to be the positive one, so just trying to get as much solder on my iron as I can. Heat that up. It might take a little while because it's basically all metal, so it kind of works like a heat sink. It's just going to spread that heat around, but as you can see, I'm just trying to slowly get there with only 2 hands. 3 hands definitely helps, so if you don't have a third hand, you can buy what's called a helping hand, and it will hold either your solder or a component in place while you work on it. So just going to, before I go any farther, put some black heat shrink tubing just down the wire, so that way I can move this up. Once I'm ready with this, good to go, I'm going to shrink that tubing in place over top of this connection, but for now, I want it in place just so that I can have it there. And going to heat up the solder I put there, and it should bond to that wire relatively easily. So now, with both the positive and the negative attached to that power jack, we are good to try and test it, I think. And there we go. So that is now out. This, honestly, can just stay there. It's not really integral to anything anymore. So we'll just tighten that up and leave that alone. So let's, I think we are ready to test this. So I'm going to get my RF set up, get this, just throw it in the shell briefly and see on the off chance that it works. All right, so cartridge in. Let's just do a quick test to the power button. 10 volts, 10 volts, 0, 0, 10, 10, 0, 0. Output of the regulator, 1 volt input, 0. And this regulator here, 1, and still 0. Well, I'm gonna have to do a little more troubleshooting, I think. Alright, so let's see what happens here. Push the button. Nothing really goes on. Once again, nothing. I do note that there is an LED. I was wrong originally. So I was hoping to see that flash when you turn the button on, and I'm getting nothing. So I'm wondering, maybe this is an issue with this button here. So let's investigate a little further. So I did a little bit more research on this, and I found out something. Turns out that the power supply that I have here, the 9 volt AC output, is actually not correct. This is for an old Atari disk drive, for an old Atari 800 system. So this system is supposed to take DC current, and what happens when you put an AC power supply into here, you can cause problems. Namely, things such as the voltage regulators or transistors are prone to fail, which seems to be what happens because I'm not getting any voltage here. So what I've done, I've found a schematic here that I've been following, and just going to show you quickly. So this is the power jack that I've installed, and following the power brings us to Q6 and Q7 right in the middle of the screen here, and then to the 7805 that's labeled VR1 and VR2, which are those voltage regulators. So that tells me that voltage is supposed to run through Q7 and Q6, or Q6 and Q7, I believe. And then from there, if we follow this trace, actually, the collector should, right here, output that voltage all the way up and go straight into the voltage regulator. However, when I go into DC test mode, so just make sure that I'm connected to everything here. So I've changed to a approximately 7.5 volt DC power supply, just so that I can test some voltages here. I'm not trying to get this going. I don't actually have an appropriate power supply for this right now. So I'm just going to test some voltages, but I'm getting 7.5 volts roughly into the, which one am I looking at here? Into this transistor, I'm getting about 7 volts, which sounds about right. Out of the collector, oops, I'm getting nothing. Then out of the base, I am getting 7 volts. So one thing I've noticed that I want to share here is you see these labels beside this voltage regulator. This is a just a regular old 7805. It has the O right on the left there and the I on the right above where it says VR2. That stands for output and input. So the idea is it inputs whatever voltage, 9 volts in this case, and will output a steady 5 volts. Now, looking at what the 7805 is supposed to look like, it appears that the output is supposed to be on the right and the input on the left. But that's not what we've got here. Same thing on this side. We've got, where are we here? Input on the right. There's no output label, probably because they cut away part of the board here. But it's almost like these were installed backwards. And then I flip this over and I see some flux along here and along the RF modulator, as if someone tried reflowing these joints, but you don't see that flux anywhere else on the board except for here. Oh, that was that RF cable, so that may have been me desoldering. But you don't see that flux anywhere else, so I'm wondering if someone tried taking these off and reinstalling it and reinstalled it backwards. Okay, so I've done some more troubleshooting. So I've done some more troubleshooting, and I think that I have, well, not solved it necessarily, but I think I've narrowed down some of my search. So I'm going to walk you through what I've done. Using the schematics has been very helpful. Been able to see where the power comes in, where it meets up with these voltage regulators, where it goes throughout the rest of the system here. So I'm just going to show you the schematic one more time. Power is going to come in through C45 right here, travels to Q6 and Q7, which are these two transistors right here, which turns out they test fine. Those were not affected by using AC power before. After Q6 and Q7, it goes into the voltage regulators. However, it requires some input from here in order to get the voltage to go that way. Sorry, where are we here? It requires some input from here in order to feed voltage to the 7805s. So I guess that means that the issue now lies in this area. And my suspicion is that's right here, which is where that power switch is. So you'll see that it says 1, 3, 5, 6, and the arrow's pointing there, and then 2 and 4, it doesn't have an arrow to it. Those are both points that the switch can go to. So those numbers are actually written on the board. So there's 2 in the corner, 5 at the top, 3 on the right, 4 on the right. 1 is kind of hidden under there, but those are contact points on this switch. So I have this plugged in. Once again, it is a 7-volt DC power supply, not the proper 9, so I really don't think everything's going to work properly. However, I do expect that there should be some voltage going through where we need it to be. So looking at the voltages that I'm pulling up, I touch the transistors and I get nothing. Why is that? Make sure everything's plugged in here properly. There we go, 7.5 volts roughly. I touch the transistor, 7 volts. Transistor here on the emitter, 7 volts. On the base, 7 volts. So in this particular case, I'm looking at Q7, which will be this one here. So on the base, I get 7 volts. That tells me that we need to move along down the circuit. So I had to look through the board for R61, which I believe is right here. And I'm getting 6 volts, which seems okay. R61, if I test continuity, should connect directly to the switch. And then the bottom points, so 4 gets continuity. How about 2? 2 also gets continuity. However, try it with some voltage to test voltage, and so I have nothing right now on the top. Why is gotta get grounded. There we go. So I have 6 volts going into that resistor. I have 6 volts on the top of the switch, 6 volts on the top of the switch. I should have 0, and I should have 0. Now, holding on that point, push the button. I have 6 there. I should also get 6 down here. Oh, turns out I am. So these, maybe it's not the power switch then. So going back to continuity, I've traced this further. Connects to this resistor, and this resistor connects to ground. So we've reached the end of that circuit. Continuity again, we're now going into this chip right here. So there is a good chance that this chip may be defective now that I think about it. Let's see. So that should be pin number 6 that I was connecting to there. So 1, 2, 3, 4, 5, 6. Yep. That sounds about right. However, does that connect the same one over here? It should. Yes, it does. From the top of the circuit here, or the top of the switch, sorry, so pins 1, 3, 5, or 6, I should be connecting to pin 4. So 1, 2, 3, 4. So I am getting continuity there. 14 should give me continuity to the other side of R61. So right there. And pin 5 and 3 should be getting me to R62, which, oh, I gotta find that. Maybe here. Anyways, so that was pin number 3, I said. And there it is. So that pin, also pin 5. And there it is. And that connects to that as well. So this is going to need some further investigation. All right, so I think I've isolated the cause of this issue, and that's this chip right here. So this is a CD4013BE. Basically what that is, it's called a flip-flop. And what that does is it stores a power state. So how it works, the power button here, when you push it, it briefly sends voltage through this pin into the chip. When you let go, the voltage disappears. This chip stores that voltage on or off. So it stores that in memory and outputs voltage to the power system. So how it works, you get constant voltage going in from the top pin, pin 14. So as you can see, we have about 6 volts. When you push the button, you should get voltage coming in through pin 10, I believe. There we go, pin 10. And when you let go of it, it disappears. Now what should happen is you should get voltage coming out of pin 13 when you push it once, and it should start sending out voltage. You push it again and it should stop. As you can see, that's not working. So what's happening is something in here doesn't work, probably because the incorrect power supply was used, sending AC voltage in, probably frying this. So what I've discovered as well is if you bridge pin 14 and 13, LED comes on. So that's telling me that this just isn't working properly. I've checked the data sheet for this, and even though we're only sending in about 6 volts, that is within spec, and it should still work. So what I've done is I've ordered some replacements for this chip, and they're a different manufacturer, but it should work. No, that's the wrong one. There they are. Should work the same way. So I got actually 10 of them. There's only 9 here, but I've taken one out. This is a Texas Instrument chip, CD4013BE. So same basic thing as this. So I'm going to remove this, replace it with this, and see if it works the way that I think it should. So first step, as always, before desoldering is add more solder. All right, that should do the trick. Let's just clean that up a bit. And now my handy desoldering pump. All right, so let's see if that does the trick. Well, second option is if you're having trouble getting a chip out and you know that you're not going to be reusing it, as is the case here, you can cut the legs, or you can try to. This is a just kind of tight space here. Oh, there we go. And we're out. Just wasn't able to really grab that chip, so looks like we are good. Chip is out. So let's clean up those pads. Just going to use a Q-tip and some isopropyl alcohol, and then going to reassemble that. So important to note, I forgot to mention it earlier, but make note of the orientation of this chip. So you can see the little indent here at the left side. There's a marking on the board as well that will match that, and yeah, you can see it right there, how it kind of dips in. So that means that the chip is going to go in this way. It's important that you put it in correctly. Otherwise, it's just not going to work. At the best case, worst case, you could damage something further. So let's clean this up. Let's get the chip lined up the way we want. So it's going to go just like so. And a couple, there we go. So that's in. I'm going to flip her over, going to apply some flux, and just going to tack in 2 corners. And then that just frees up my other hand so that I can come back and properly solder this in. So flux these up. I'm going to load up my soldering iron just with a bunch of solder. Here. There we go. So load up the iron and tack in one corner, tack in the other corner. So that's not a secure joint, but it's just holding that chip in place so that I can come back now and properly solder these in. So I'm going to start at the top left here. Oops, get a better angle here. Okay, so let's give that a once over. Just want to make sure that those joints look solid. Yep, no cold joints there. So clean that up with some isopropyl alcohol again and a toothbrush, just to get that flux off. And then we'll give her a try again. Okay, so new chip's in. First thing I want to check is just, let's turn it on, see if that LED comes on. And it does. So that tells me that I was right with this chip being the problem, so it was not sending voltage. Let's make sure that my theory was correct, that pin number 10 should be reading voltage. Oh no, sorry, pin number 13, and we are 6 volts. Turn that off, pin 13 is giving 0. We're getting 6 volts continuously through pin 14, which is the way it's supposed to be. Bridge those two and we get voltage. Sorry, I hope I'm not covering the LED. Bridge them, we get voltage. Same thing there. Turn it on and we get continuous voltage coming from pin 13. So it looks like that works. I'm curious whether this would actually work now. Maybe that was the only issue, so I'm going to try it. Actually, I should check out that voltage regulator. That was sort of the whole point of this. So let's make sure that we're getting voltage through here. So we've got the multimeter there, and 5 volts through the, it's labeled input, but I think this is actually the output. And through the output, getting 6.67. So they definitely mislabeled this board, because I'm getting supply voltage through the output, and we're getting regulated voltage through the input, which is backwards, of course. Then up here, getting nothing. And what about here? Still nothing. So I'm curious why this doesn't do anything. But we're at least partway there, so let's hook this up, see what we got here. All right, so we got it all set up. I got the RF cable plugged in here. Let's see what we got. So power on. Oh, TV set up. Power on. And oh, we are actually getting it. It's really fuzzy, as you can see, but it works. Let's try. Oh, switching that doesn't help. Oh, and we lost it. So I was just playing with the channel select here, so. Oh, and so when I switch the channel, I lose power. I don't think that's supposed to work that way, but let's try to clean that a bit. So we're definitely getting a short somewhere. And it could just be that this is not insulated or anything properly yet either. And I almost forgot, I'm not using the proper power supply, so that could definitely explain why this looks so terrible. Odds are good that proper voltage would work better, but I'm also going to try adjust this pot here a bit. Nope. So that's changing the color. Let's get back to that title screen. So we should definitely have color there, so I think this is probably a good value. I'm not sure what this one does. I'm not going to play too much with it, but yeah, there's no sense continuing until I get the proper voltage coming through this power supply, so I'm going to order myself a power supply now that I can get the power circuit working, and see what we can do from there. Alright, so I've managed to find a power supply that matches what the original would have been, which is 12 volts, 2 amps. So it doesn't really fit here, so what I've had to do is kind of finagle a solution where I'm running leads into the system here and going to try and run off that. So let's plug it in. So we should be able to see that, where's my negative lead? There we go. That we are getting 12 volts, 12.2 volts, so that's good. So let's power on, see what we've got here. So we are still getting some significant noise, but it does work. So could be issues with this RF box here, or this connector, or this cable I'm using. I could always try a different RF cable. Let's do that right now, just to rule out the that RF switch. So I did try one more RF switch. Like this is the kind that you get from a Nintendo, and I'm actually getting even worse. I couldn't get anything, to be honest. So I'm pretty sure this is going to be either something to do with the RF here. So I'm going to also look into maybe a composite mod for this instead. And if we can bypass this old crappy RF, that would probably be ideal. So I'm going to end this video here. So this was basically just repairing the power circuit, which turned out to be this controller right there, linked to the power switch. So having done that, we get the games actually being read, and we are getting video. Now I haven't even tried a controller yet, so I don't know that that works, but the power portion of this is complete. So hopefully you found it interesting at least, although I know it did go a little bit long, but there's a lot to this board, and probably going to be at least a 2 or 3 part series here. As like I said, we haven't even started going into the controllers yet. So that's going to be it for today. Really appreciate you watching. Hopefully you enjoyed the video. Leave me a comment below. Let me know what you think, or if you have any suggestions for me. Always open to suggestions as well. But in the meantime, thanks a lot for watching, and we'll see you in next video.